Okay, moving into chapter 6, the periodic table and periodic law. You can see that there are 3 sections. Section 1, development of the modern periodic table. Section 2, classification of the elements. And Section 3, periodic trends. The entire chapter, I take that back. Section 1 and Section 2 should be review. Section 3 is going to be new material based off of that reviewed material. So the big idea for this chapter, periodic trends in the properties of atoms allow us to predict physical and chemical properties. Okay, our objectives for section 1, trace the development of the periodic table, identify key features of the periodic table, our review vocabulary, atomic number, remember that is the number of protons in an atom. So when you're looking at the block on the periodic table of that specific element, it's the smaller number. Main idea in section 1, the periodic table evolved over time as scientists discovered more useful ways to compare and organize the elements. Here's your whole list of new vocabulary. Periodic law, group, period, representative elements, transitional elements, metal, alkali metals, alkaline earth metals, transition metals, inner transition metals, lanthanide series, actinide series, nonmetals, halogen, noble gas, and metalloid. Okay, so Lavoisier compiled a list of known elements at the time. There were 33 elements, and he organized them into 4 different categories: gases, metals, nonmetals, and then the earths. And you can see how he had them organized here. So the gases, he had light, heat, so on and so forth. The metals they knew at that point in time. Remember, this is back in the 1700s. Antimony, silver, arsenic, bismuth. Non-metals, they were sulfur, phosphorus, and so on. The earths, chalk, magnesia. So if you look at those, you can see that these are the ones that were actually made in the earth. As electricity was invented, it was a lot easier for them to be able to break down the compounds in the elements, and they were able to identify more and more. So the electricity definitely helped with that. So, whoops, let me go back. In the 1800s, the more technology, once again, that they were finding, it was easier for them to find new elements, and then they had to organize those new elements. In the 1860s, scientists agreed to organize the elements by their atomic mass. Okay, remember, atomic mass is going to be the number of protons plus the number of neutrons. Okay, so they were trying to search for, as they were organizing these, trying to search for a relationship between that atomic mass and all the properties that came along with those elements. So John Newlands proposed an arrangement where we put them according to their order by increasing atomic mass. And then as they were placing these out, he noticed that the properties of the elements seemed to repeat every 8th element. So as it became repeating, they noticed the repeating pattern. They called this periodic. Newland named this relationship the law of octaves. If you've ever played a musical instrument, you know that a group of 8 elements is an octave, and that repeats every 8th tone. So that's how they got the law of octaves. This law did not work for all the known elements, and this law was not accepted. However, later it was learned that he had the right idea. We just needed a little more information to get things to work right. So you can see in this next one how he had things laid out. Okay, so he noticed that when the elements were arranged by increasing atomic mass, they had repeated properties every 8th element. And you can see this is 1 octave, or octave as they call it here. Okay, so then we go on to a couple more scientists, Meyer and Mendeleev. They each demonstrated a connection between the atomic mass and the elemental properties. Mendeleev was given more credit because his idea was published first. He noticed that the elements were ordered by increasing atomic mass and periodic patterns of properties. His idea became widely accepted because he predicted the existence and properties of undiscovered elements that were later found. And we're still finding that today. There are still spaces in there. He left those spaces, and some of those elements became found. Okay, so Moseley came in and rearranged the table a little bit to make it make more sense. So we have the Moseley and Mendeleev table was not completely correct. After a few of the new elements were discovered, it was learned that several of Mendeleev's were not in the correct order. So Moseley, like I said, rearranged those according to atomic number, not atomic mass. And this seemed to make more sense. The statement that there was periodic repetition of chemical and physical properties is now known as the periodic law. Okay, so you can see here the scientists that contributed to the organization of the periodic table. We had John Newlands, Meyer, Mendeleev, and Moseley. And they all, just like when we were looking at the atom and how we came up with the proton, neutron, electron, they all kind of built on one another. So now we're going to talk about the modern periodic table. This is where this should be reviewed. So the modern periodic table contains boxes that have the element's name. Okay, let me get my arrow here. The element's name, the symbol, the atomic number, which remember equals the number of protons, and the atomic mass, which is protons and neutrons. And then the one in your book is really nice because it gives you the state of matter. Is it a solid, liquid, or a gas? Okay, columns of elements are called groups. The rows are called periods. Okay, elements in groups 1 and 2, jump over to 13 through 18, possess a wide variety of chemical and physical properties. They are called representative elements. Now remember those ones in the middle, those ones that have their own rules some of the time, in groups 3 through 12 are called transition elements. Okay, elements are also classified as metals, nonmetals, or metalloids. Metals are elements that are generally shiny when smooth and clean, solid at room temperature, and good conductors of electricity. Alkali metals are those that are in group 1. Except for hydrogen, they're very reactive. Alkaline earth metals are in group 2, and they're also highly reactive. The transition metals are divided into the transition metals and the inner transition metals. The two sets of inner transition metals are called the lanthanoid and the actinoid series, and they're located at the bottom of the table. And remember, the reason they're pulled out is so that they fit on one page. They fit in the periodic table. Nonmetals are the elements that are generally gases or are brittle, dull-looking, and solids, poor conductors of heat and electricity. Group 17, we call those the halogens. They are highly reactive elements. Remember, they want to gain that one electron to get to be to the cool group, to group 18, the noble gases. In group 18, noble gases. Those are the cool kids because they have a full outer shell. Metalloids, they have physical properties, physical and chemical properties of both metals and nonmetals. Okay, so they lie along, they're the green ones here, they lie along this, these are the nonmetals, the yellow, the blue are the metals, and the metalloids lie in between, so they have characteristics of both. Now I'm going to go to the textbook website and we are going to watch this video.
Columns of elements are called groups. Elements in the same group have similar chemical properties. Rows of elements are called periods. Atomic number increases across a period. The arrow shows where these elements would fit into the periodic table. They are moved to the bottom of the table to save space. The first three symbols tell you the state of matter of the element at room temperature. The fourth symbol identifies elements that are not present in significant amounts on Earth. Useful amounts are made synthetically. The color of an element's block tells you if the element is a metal, non-metal, or metalloid.
Okay, and you have a copy of this in your textbook, and I've given you a couple copies as well. Okay, so let's go back and take our quiz and see how we do. Okay, what is a row of elements on the periodic table called? Answer is period. Remember, the earlier scientists had said every 8th element, they had repeating elements, which was periodic. Maybe that'll help you remember that one. What is silicone an example of? So now you need to look at your periodic table, figure out where silicone is. Is it a metal, a non-metal, an intertransition metal, or a metalloid? Yes, it lies in between the metals and the non-metals. It is a metalloid.